Assalamualaikum, students. Students, in this recorded lecture, we are going to describe the solubilities of group 2 sulfates and the solubilities of group 2 hydroxides. We know that the solubilities of hydroxides, it increases down the group, and the solubilities of sulfates decreases. They are opposite of each other. And now we are going to describe these solubilities in terms of enthalpy changes, right? So to start this, I'm going to share the screen, but when I'm sharing the screen, you are supposed to what? Tell me. Like and share and subscribe. I think the sequence is correct, huh? Like and subscribe and share the channel. Okay. And it's what? It is the notability, huh? Group 2. Group 2 of A2. Yes, this one. So before this, we have done what? We have done the simple observations of group 2, and then we know, you can see the hydroxide, they are becoming more soluble, but the sulfate, they are becoming what? Insoluble. But before going to describe this, if I ask you why ammonia is soluble in water, then what would be your answer? It can do hydrogen bonding with water. Or why NaCl is soluble in water? Now, if the question is about covalent thing, why covalent things are soluble in water? You know why? The covalent things, they do hydrogen bonding with water if they're soluble, like ammonia, ethanol, carboxylic acids, amines, they all can do hydrogen bonding. But when the question is about ionic compound, if NaCl dissolve in water, this shows that its delta H solution is what? Exo. If AgCl is insoluble in water, its delta H solution is what? Endo. Right? So we are going to describe these two in terms of their enthalpy changes of solution. So look, these are the notes. Like it's a small topic. The questions are quite simple, clear, 3-mark question, 4-mark question. Sometimes in the old papers they were of 4 marks, but now they are just of 3 marks. Like you have to describe the trend, right? In terms of enthalpy changes. And what are these enthalpy changes? Do you remember in energetics? That in energetics, look, we used to do this way. I'm opening the energetics. This way. See? When there is any ionic compound, we write what? Cation and anion. The cation and anion first making lattice, the lattice in water is solution. 1 mole of ionic lattice from gaseous ions, 1 mole of ionic lattice dissolve in excess water, solution. And the ions dissolve in excess water is hydration. So actually hydration enthalpy is the sum of lattice plus solution. Delta H lattice plus delta H solution is equal to what? Hydration. So if I make the solution subject, what I will get? Hydration minus lattice. Now coming to that topic, how we are going to describe. I am doing this here. Suppose I'm going to take. Okay. Suppose we know this, that beryllium sulfate insoluble soluble. Magnesium sulfate, soluble. Calcium, strontium, barium. They're all getting what? Insoluble. They are ionic when they are getting insoluble. Their delta H solution is getting what? Endothermic. How we are going to describe these, the delta H solution to be endothermic down the group, like what is the reason? Look. Delta H solution, if I make it subject, the formula become what? Delta H hydration minus delta H lattice. Okay. Now, suppose I'm using beryllium sulfate. Hydration. You know, beryllium attracted by water, sulfate attracted by water, beryllium attracted by sulfate lattice. If I do the same thing for barium sulfate, barium hydration attracted by water, sulfate attracted by water, barium attracted by sulfate. Now, one thing that you can see. If you look at this hydration and lattice, the ions attracted by water, the ions attracted by water, the beryllium attracted by sulfate ionic lattice, one more of ionic lattice from gaseous ions. Now, down the group, what is happening? Why they are becoming less soluble? Why it is becoming what? Less soluble. Down the group. Is there any change in sulfate down the group? No. Where is the change? In the beryllium to barium, beryllium to barium. But the size increase, the size of cation increase. When the size is large, the electrostatic forces of attraction are weak. When the size is getting large, the attraction of beryllium with water is more, the attraction of barium with water is less, beryllium with sulfate is more, barium with sulfate is less. It's more exo, it is less exo, more exo, less exo. Now, for example, मैं अपनी मर्जी से values use कर लूं, मैं I use just values, the generalization. If I do the generalized values, they're not specific values. I'm using this on my own, like my own values. Suppose, for example, it is how much? Minus 1000, both. And this is how much? Minus 800, I have written. Okay. Minus 1000, this is minus 100. You know what is happening down the road? It decreases. And it decreases to how much? Suppose minus 400. And this also decreases, to how much? Minus 700. Look. Smaller, more attraction, smaller, more attraction, more exo, less exo, both decrease. Less exo. Which one decreases more? It is changing from 1000 to 400, from 800 to 700. Look, 1,000 released, 800 released, 400 released, 700 released. Both decrease. Both decrease. Both decrease. But which one decreases much more? The hydration. You know, the upper is how much? The solution is how much? Minus 200. This is how much? Plus 300 endo. Look, down the group, size of cation, down the group, size of cation increase, delta H hydration, delta H lattice both decrease, getting less exothermic, but the hydration decreases more significantly. Right? Listen. Down the group, the size of the cation increase. In case of sulfates, the size of cation increase, the delta H hydration decrease, the delta H lattice decrease because the attractive forces are getting weak. The hydration decreases more, the change is more significantly. But when we will do the same thing for the hydroxide, the delta H lattice and the delta H hydration both will decrease, but in case of hydroxide, the lattice decreases more. Right? As a result, their delta H solution will be becoming exothermic for hydroxide, but for sulfates, the delta H solution is becoming what? Endothermic. Look, I'm sharing the screen again. Down the group, in case of sulfate, size of cation increase, delta H hydration decrease, delta H lattice decrease, but hydration decreases more. As a result, the solution is getting endo. If I do the same thing for hydroxide, it's like this. Beryllium hydroxide, delta H solution. Beryllium attracted by water, hydroxide attracted by water. Delta H hydration, beryllium attracted by 2-hydroxide lattice. For barium hydroxide, barium attracted by water, hydroxide attracted by water, barium attracted by 2-hydroxide. So is there any difference in the hydroxide? No. Down the group? So where is the difference? Is the size increase? Yes. Attractive force is weaker. Suppose it is minus 1,000 that is released. Beryllium attracted by water, hydroxide. What I did? Look. Size of cation increase. Attractive forces more, attractive forces less, more exo, less exo, right? And suppose it is changing from minus 1,000 to minus 800. It's getting less exo. And it is minus 1,500. And this decrease, and it becomes how much? Suppose minus 600. For instance, now what you can see? The size increase, attractive forces strong and strong, weak and weak, decrease, decrease. But this decreases from 1000 to 800. This decreases from 1500 to this. Which one decreases more significantly? The delta H lattice. What is the sum of this? Endothermic, insoluble. This is what? Exothermic, soluble. This is soluble, this is insoluble. So if you see hydroxide, if you see sulfate, you will find the down the group size of cation increase, size of, like look at these two, size of cation. There is no change in sulfate, no change in hydroxide. Size of cation increase, size of cation increase in case of sulfate and hydroxide. In both, the hydration decrease, the lattice decrease, the hydration decrease, the lattice decrease, 1000 to 400, 800 to 700 decrease, 1000 to 800, 1500 to 600 decrease. But in case of sulfate, the hydration decreases more. In case of hydroxide, the lattice decreases more. As a result, the delta H solution is getting exo here and it's getting endo here. Therefore, it is becoming what? Insoluble down the group, and hydroxides are becoming soluble. Now, if we go to the notes again, these are the notes. You can see down the group size of cation increase. Delta H hydration and lattice both decrease less exo. Hydration decreases more than lattice. Delta H solution is therefore getting endo. But what about solubility of sulfate? They're becoming more soluble. Delta H hydration and lattice both decrease. But here, the hydration decreases more. Here, the lattice decreases more. The solution is getting more exothermic. You know, one thing, if anything is more soluble in water, that thing has more attraction for water. And that thing can be used as a drying agent if it is solid. Any substance more soluble in water has more affinity for water. They absorb more water too. So if they're solid, they can be used as a drying agent. And your group 2 is over. Now you are supposed to do the practice of the group 2 questions from the topical that are on my website, Chemistry by Zeenat. And now like, subscribe and share. Okay, bye. Allah Hafiz.